Hey, how are you today? Going to do one of our final lessons today, and that is on something we call slopes of a line. Okay, so we're done with equations pretty much, at least in this lesson. They'll come back in the last lesson, but we're going to talk to you about slopes of a line, which is a very important concept that you'll learn a lot about next year. So what is slope? Well, slope is the rate at which a line changes from left to right. Okay, it describes how steep the line is. All right, mathematically, we think about slope as how the line rises compared to how the line runs. Okay, so instead of rise, you could say change in the y variable, and instead of run, you could say change in the x variable. And the y variable makes the line go up and down vertically. The x variable makes it go left and right horizontally. And remember this little phrase because it is often mixed up. You must rise before you run. All right. Down below there are three lines here. And just looking at them, you could tell whether your slope will be positive, negative, or zero. All right. So the first line, okay, is it positive, negative, or zero? First line is going to be positive because you're looking at how it changes, and it's going up from left to right. Okay, so when you're looking at the line, you always want to look from left to right. So I see this corner is like down, but as we go from left to right, it goes back up. All right, this one is a negative slope because it's going down from left to right. And this last one, the slope is zero because it is a flat line. All right. And why do we learn about slope? Because describing how steep something is pretty important, especially if you're working on roofs, okay? Engineers, mountain climbers, ski slopes, all right? All that has to do with slope. All right, so we're going to do a couple examples here of finding the slope, a couple basic ones here. All right, so you have a line, you want to figure out the rise over the run. Okay, up and down over horizontal. Okay, so just remember rise over run. And that's y over x. So between these 2 points, and actually you could go between any 2 points you could see clearly on the graph, and then just make sure to reduce your fraction. But between this point, you're going up 2. All right, so that's going to be my rise, 2. And my run is going to be, all right, so we're going from -1 to 4. So that's going to be 5. That's going to be my run. So my slope is simply 2/5. Okay, and you don't have to reduce that one. All right, let's look at this one. Okay, so remember we're going from left to right. It's always easiest to go from L to R, from left to right. Okay, and this one, you can see this line is slanted downward, so we know that we have a negative slope. Okay, so we're going to start by going down from left to right. Okay, we're going from 5 to 2, so that is a -3. So since we're going down, we write a negative, and then we're going to go across. We're going from -1 to 4, so this is 5 again. So we're going to write 5 again, and so our slope is -3/5. Okay, so remember if you're going down, it's going to be negative. If you do left to right, you will always go right, okay? For some reason, if you go, you start with the wrong point and you go right to left, you would have to go up 3, okay? So if you go up 3, then you go left 5. And since you're going left, left counts as a -2, okay? So the difference is you would have a negative on the bottom instead of on the top. But actually these two things are the same anyways. The negative sign is free to move from the bottom to the top, okay? But it cannot be written 2 places because that would cancel it out. All right, so let's take a look at one of the book problems here. Let me pull it up. There it is. Okay, so I want you guys to see if you can figure out the slope of this one here. All right, so this one's a little bit trickier because they're not numbering simply by 1s and 2s, okay? And you can't just count all the lines. All right, so the rise is the difference between 60 and 90. Okay, so it's rising a total of 30 here. We're going up 30. So our rise is 30 in this one. Our run, Okay, we're from left to right, we're going 2 over. So we have 30 over 2, and then we reduce it so that the slope of the line is equal to 15. All right, so this would actually represent, since we have units on here, it's good to think about what these units represent. This line is going this is a charity ride, a 3-day charity ride, and it's biking. Okay, she's biking 15 miles per day in this charity ride. All right, now the neat thing about lines is the slope is constant. Okay, so if we figured out the slope between, say, these 2 points, it would be the same thing. Okay, we would go up here. Okay, so we would go up 30, because each line's actually worth 10 here, if you didn't catch on to that. 10, 20, 30, and then you'd go over 2. All right, so 30 over 2 is 15 miles per day as well. So it doesn't really matter what 2 points you pick, as long as you can actually see them on the graph, you can, and as long as you're doing rise over run, you got it. The slope will be the same for any 2 points that you pick. That's the point, okay? As long as you can count good as well. All right, so now, what if you don't have a graph, okay? Well, there's actually a formula that you can use if you don't have a graph and you just know the points, all right? So like I said, you can use any 2 points. I said it again, you can use any 2 points on a line to find its slope, all right? So a point, remember, is labeled x, y. Okay, now we're going to add these little subscripts 1 and 2 on them to represent point 1 and point 2, because you have 2 points on the graph, all right? So in this picture we have PQ. So you could find the slope by counting again, you know, up and over. But if you don't have a graph, you can't really count that way, okay? So you could use this little formula to figure out the slope, which is the change in the y variables, so y2 minus y1, over the change in the x variables, x2 minus x1. All right? And, I mean, if you switch the points around, you could do, it would still work out, okay? You would just have negative signs that will be like maybe on the bottom instead of on the top, like we saw in the one example. But try to label the first point you see from left to right as the 1 point and the second point as the 2 point, and you'll have less negative signs to worry about here. Okay, so let me show you an example here of how you can use this formula. So you have 2 points, -2, 1, and 5, 7. If we're going to figure out the slope using those points, all right, so here's the formula. We just substitute, okay, so y2 is 7, all right, y1 is 1, okay, so we're subtracting the 2 y values. On the bottom, we're going to be subtracting the 2 x values. So we'd have 5 minus a -2, okay? Now, if you remember, if we take and subtract a negative number, so we're subtracting a negative, guess what that means? We're actually adding, okay? So anytime you are subtracting a negative, you are adding. So you can just change the bottom into 5 plus 2. So you really have 6 over 7 for your slope. All right, let's look at another one from the book here. So let me get back to that. Where is it at? Where is it at? Panic. Okay, there it is. All right, so here is example 2. You have a little video problem here, but basically you have a submarine that's diving and you want to figure out the slope, which represents in this problem how many feet per minute that the submarine is diving, okay? So let me clear out this ink. Oop, there we go. So how many feet per minute the submarine is diving? Well, you don't have any points labeled, but you can find the points, so let's just play the video.
Now substitute values for the variables. For the first point, the x-coordinate is 5, and the y-coordinate is -400. For the second point, the x-coordinate is 10, and the y-coordinate is -800. Now simplify the fraction. The numerator is -400, and the denominator is 5, so the fraction simplifies to -80.
There you go.
The slope of the line is -80. The submarine is descending at a rate of 80 feet per minute. How do the x and y coordinates relate when the slope is negative?
All right. Interesting question. What do you think?
When the slope of the line is negative, the x-coordinates increase as the y-coordinates decrease. In this problem, the negative slope shows that the submarine is descending as time passes.
Cool. All right, let's do another one here. All right, here we got another graph. The graph shows the distance a car travels over time. Find the slope of the line. What does it mean in the problem situation? All right, so you could do the counting method again, all right, but you'd be like counting in between lines, so it's kind of a little tricky to do it that way. So since we have the points labeled, we could just go ahead and use the formula. And this formula right here, okay, oh, by the way, I don't think I told you that you can use the letter M to stand for slope, okay? So if you see the letter M, that stands for slope. But anyways, this formula right here is very, very critical that you guys get down and can use y2 minus y1 over x2 minus x1. So that's the formula we're going to use. And okay, another thing is, you want to label your points, okay, before you go and use the formula. So the first point you see from left to right is typically the one you call x1, y1. Okay, you have an x coordinate and a y coordinate. The second point that you see is x2, y2. All right, and then you just substitute and you can solve it. So let's actually do that right now here. Substitute and solve. Oh, go away there. All right, so we just substitute, okay? Like I said, y2 is 220. All right, actually they have a typo here. Typo. Yeah, so this is 220. Okay, 220 minus 110 is 110. All right, so that was a little typo on the book's part there. They got the right answer here, though. 110, oh, and 4 minus 2 is 2. Okay, so remember, x2 minus x1 is 4 minus 2, so that's 2. And so you get 55 for the slope. And in this situation, okay, the first unit is the y unit, okay, that's miles. And then the second unit is hours, because remember, it's rise over run, and rise is y over x. So the car is traveling at 55 miles per hour. Pretty cool. All right, let's have you guys try one. Here we go. Now I want you to use the formula. Don't try to do the counting method, just practice using the formula here. You can do the counting method on some of the ones on your homework, but try to use the formula too. All right, go ahead and figure out the slope. What's the slope? All right, let me tell you what the slope is here, or help you work it out here. Get rid of this ink. Let's make it a little thicker so you guys can see what this ink says here. All right, so there's your 2 points. First thing I would do is label them x1, y1, x2, y2, like so. All right, and then remember you're using the slope formula, m for slope, y2 minus y1, changing the y's, or the rise, over the change in the x's, like so. All right, substitute. 70 is y2, minus 35, that's y1. On the bottom, we have 50, minus 25. Okay, 70 minus 35 is 35. 50 minus 25 is 25. All right, and so you can reduce that then, divide both by 5, so you have 7. 25 divided by 5 is 5. So that would mean you would have 7, okay, look at the units, red drops for every 5 blue. So 7 red for 5 blue drops. Okay, and that kind of describes what this means for the situation. Okay, guys, that's about it. Remember, there's 2 main ways to find the slope. You can count with a graph, as long as you're counting correctly how many it has risen over how many it has gone to the right. Okay, so rise over run. Or if it is going down, it's a negative over a positive, so your slope might be negative. The other way you can do it is label your points, x1, y1, x2, y2, and then use the formula. Okay, make sure you know this formula. All right, that's about it. Have a great day. God bless. Bye-bye.